Heyo everyone, today I figured I would help you all with solving physics problems since we have done a little short tutorial app review thing for physics apps to help you solve. I figured, you know what, I'll just take you through a little course. We'll do different kinds of problems. This time we're using a distance time equation, and here's the problem. An airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So just right away when we're looking at the problem, we can immediately see acceleration. Then airplane accelerates down a runway at 3.2 meters per second squared. So let's go and make a little givens chart. We'll go and we'll throw in some acceleration, and then we can also see there's time for 32.8 seconds. And then the rest, well, besides for it asking for the distance traveled, which is like, okay, we're trying to find distance. We're going to write that as x of f. But basically, it's also physics, kind of like a, you got to assume things. They're just given things like how gravity is always 9.8 or 10, or for the acceleration of gravity, that is. That's what we would put g as. We're not going to get into that, though. For you new people who don't know that, you're probably really confused. Like, there's a difference between 9.8 and 10. And there is. It just depends on how you want to solve it and if you want a cleaner answer. But anyways, back to this problem. So, since it's an airplane on a runway, we assume it's going to start on the ground at the starting point, because it wants to know how far it goes until it takes off. So, the initial position we're going to mark as 0. And then since it's not moving initially, the initial velocity, which is basically its speed, for like a quick sum up of what velocity is if you don't know, we're just going to put that as 0 too, because if you're not moving, well, you're not really, you don't have any speed, you don't have velocity. And so once we have all the givens, and then we know we're trying to find the final equation, so we're going to look at our little equation sheet. It has all of the different kinds of problems, and oh, there's one right there. It says we're trying to find final position, and then there's initial position, initial velocity, time, 1/2, which is just part of the equation, and then acceleration and time. So we're going to write out the equation x of f equals x of I plus v of I t plus 1/2 at squared. And you might be seeing those little like pluses of the box around it, or the lines on each end here. What the heck are those? That's just my little cheat sheet, so that way when I'm writing down problems or when someone's reading my problem, they don't get my t's and my pluses confused. And I know you can go and do a little swoop at that bottom of the t, or just make your t look different. But this is what I do. It's pretty simple. It works in math. Also, even though this is kind of math, just all around math like algebra. But anyways, once we have the problem, we're going to go and we're going to plug in our values. So we see x of I, and oh, look, in our givens, we have x of I equals 0. We're going to plug in a 0 for that. Same for our velocity initial, since we have that marked as 0 also, because well, the plane wasn't moving when it wasn't going anywhere, was it? It had no speed. And so then we can see the t. We're going to plug in 3.2, or 32.8, sorry. Getting ahead of myself with the acceleration. So we're going to plug in the t that we have in our givens, and then we're going to go over to the a, and oh look, we also have a. Wow, we have pretty much everything from the problem going into this equation. This must be the right equation. So we're going to plug in 3.20 for a, and then we're going to plug in the t again, and we're going to leave the squared alone. We're not going to mess with that yet. And so then once we're going to begin solving. Now we see there's two zeros, and anything times 0 is 0. So when we rewrite the equation, we're going to leave the second half alone and focus on the first half. That all cancels out because 0 plus 0 is 0, and then 0 times 32.8, it's 0. So now on to the second half of the equation, and if you want to, when you put this into a calculator, because you can do it in your head if you want, or you can write it down on a piece of paper. I'm going to use a calculator just to make this easier on myself, because I don't want to mess up and then lead you guys astray. But if you want to do it on paper, you can. Any physics problem can be done in your head or on a piece of paper. It never requires a calculator, for the most part, unless you're really trying Well, actually, no, even anything without a calculator can be done. But, okay, I'm getting distracted again, so we're going to solve. So I'm going to do the square root, or squared 32.8. That gives me 1075.84. Then I'm going to go and I'm going to multiply that by my acceleration. That was 3.20. And then I'm just going to jump ahead and I'm going to divide it by, I'm going to divide it in half because it's times 1 over 2. It gives me 1,721.344. And I'm going to just go and I'm going to clean up that answer a little bit, and I'm going to change it so it's 1,720 meters. That is how far the plane traveled within the 32.8 seconds until it lifted off the ground. I hope you all found this useful. I'll be putting out more tutorials in the future. Remember to comment, rate, and subscribe.